Hey, how's it going? I like bananas. They have lots of potassium and they're delicious. Did you know that you can use formulas to find the midpoint and length of any segment in the coordinate plane? Well, if you didn't, now you do. Alright. The coordinate of the midpoint is the average or mean of the coordinates of the endpoints. The coordinate of the midpoint of M is, if you got the coordinate of A is A and the coordinate of B is little b, then the coordinate of the midpoint is A plus B divided by 2. It's the average of those two. In the coordinate plane, it's a little harder. But it's basically the same thing, just once in the x direction and once in the y direction. The x coordinate of the midpoint is the average of the two x coordinates. And the y coordinate of the midpoint is the average of the two y coordinates. It's really not that bad, but here's your formula if it's on a number line. Here's your formula for the midpoint if it is on a graph. With 2 dimensions. Alright, AB has endpoints at -4 and 9. What is the coordinate of the midpoint? Easy money. A is -4, B is 9. I just need to do A plus B and divide by 2. -4 plus 9 is 5. 5 divided by 2 is 2.5. So the midpoint is, let's see, this would be 3. So 2.5 is right about there. Alright, now EF over here has endpoints 7, 5 and 2, -4. What are the coordinates of the midpoint? Somewhere around here, but let's use the formula. So let's let E, 7, 5 be x1, y1, and let F, 2, -4 be x2, y2. The midpoint is, the x value is the average of the two x values. So 7 plus 2 is 9, divided by 2 is 4.5. The y coordinate is the average of the y values. So 5 plus -4 is 1, divided by 2 is 0.5. So over 1, 2, 3, 4.5, and then up 1/2. The midpoint there is coordinates 4.5, 0.5. Bada boom. Oakley dokley. Pause and see if you can do these two. Okay, so A, JK has endpoints -12 and 4 on a number line. What's the coordinates of its midpoint? Well, we're just going to do -12 plus 4 and divide by 2. -12 plus 4 is -8. So the coordinate is -4. What is the midpoint of RS? Well, the x coordinate is the average of the x values. So 5 plus 3 over 2 for the x coordinate. The y coordinate is the average of the y values. -10 plus 6 over 2. That's 8 over 2, and -10 plus 6 is -4 over 2, and that is 4, -2. Ooh, we can find an endpoint if we have one endpoint and the midpoint. So what are, if we know that C is -5, 7, and M is -2, 1, what are the coordinates of the other endpoint? Well, we'll call that coordinates of D, x2, y2. And we're just going to fill in everything we know. So we're going to know that -5 plus the x coordinate of the other endpoint divided by 2 equals -2. And that 7 plus the y coordinate we're looking for divided by 2 equals 1. So negative 2 is negative 5 plus the other x coordinate divided by 2. We can just, and we set up the same kind of equation over here with the y coordinate. We got this 2 in the bottom over here, so we can multiply both sides by 2. And that will cancel out. We get negative 4 equals negative 5 plus the x coordinate we're looking for, and 2 equals 7 plus the y coordinate. Over here we're going to add 5 to both sides. Over here we're going to subtract 7 from both sides, and we get that the x coordinate is 1 and the y coordinate is negative 5. So the coordinates of D are 1, negative 5. Alright, go ahead and pause and see if you can do this. Alright, here we go. The midpoint is 4, negative 9. And that is the average of the x values, comma, the average of the y values. And so it's going to be negative 3 plus the x value, negative 5 plus the y value. Now I can set up equations. The 4 is going to equal this. So 4 equals negative 3 plus x over 2. And for the y values, negative 9 equals negative 5 plus y over 2. Multiply both sides by 2. I get 8 equals negative 3 plus x. If I add 3 to both sides here, I'm going to get x equals 11. Then to solve for y, multiply both sides by 2. Negative 18 equals negative 5 plus y. Add 5 to both sides, and I get negative 13 equals y. So, coordinate of the endpoint B, those coordinates are 11, comma, negative 13. Alright, distance formula. The distance between 2 points, x1, y1, and x2, y2 is, do you know it? Well, it's based on the Pythagorean theorem. Pythagorean theorem says that a squared plus b squared equals c squared. Well, if we wanted to find out what c is, we could just take the square root of each side, because the square root of c squared is c. So c is the square root of a squared plus b squared. Now how does that help us up here? If we could figure out how do we find this distance? Well, this distance is just x2 minus x1. So that becomes the square root of x2 minus x1 squared. And then the b squared is going to be the difference between the y values, which is just y2 minus y1. So that is our distance formula. If you like it written by computers, there you go. So all you do is subtract the x coordinates and then square it, plus the difference of the y coordinates squared. Add those together, take the square root. Bada boom. Also, bada bing. Alright, round to the nearest tenth. What is the distance between these 2 points? Well, distance formula is thus. So x2 is going to be 4, so we're going to do 4 minus negative 7, and then square it. And then the y coordinate, y2, so we're going to do negative 3 minus 5, square it. 4 minus negative 7 turns into 4 plus 7, so that's 11 squared. Negative 3 minus 5 is negative 8. So then we're going to square both of those. Everything should be positive at this point because we just squared everything. Then 121 plus 64, 185, and throw that in your calculator, about 13.6. The square root of 185 is the exact distance. If we round it to the nearest tenth, we get segment UV. We should have squiggly equal signs here because it's approximately equal to. It should say the length of UV is approximately equal to 13.6. Segment UV, the length is exactly 1 square root of 185. So straight equal signs should equal the exact value. Squiggly equal signs is the approximate value. Alright, pause. See if you can do these guys. Alright, let's find the length of SR to the nearest tenth. So distance equals the square root of this is the difference between the x values. So 3 minus -2. And then this is the difference of the y values. So -1 minus 14. Three minus -2 turns into 3 plus 2, so that's 5 squared. This is -15 squared. 5 squared is 25. -15 squared is 225. So that's the square root of 250. So I can say that the length of SR is exactly square root of 250, but maybe a little more helpful to visualize is approximately equal to 250 square root button round to the nearest what now? Round to the nearest tenth, so that's 1 decimal place, so 15.8. About 15.8 units. Alright, so in problem 3, suppose you let V be x1, y1, and U be x2, y2. Do you get the same result? And why? I will tell you the answer is yes, and then I'll show you why. Alright, so now we're going to do the same process, but we're going to put the points in the opposite order. So instead of doing 3 minus -2, we're going to do, oh wait, no, that's this one. Instead of doing 4 minus -7, we're going to do -7 minus 4. And instead of doing -3 minus 5, we're going to do 5 minus -3. Alright, -7 minus 4 is -11. 5 minus -3 is 5 plus 3, that's 8. And I think you can kind of see what we're getting here. These are just, this one is, instead of being positive, this one's negative. Instead of being a -8, positive 8. But it doesn't matter because as soon as we square it, we get 121 plus 64, and we got the exact same thing we do here. So that's going to turn into square root of 185, and that's going to turn into approximately 13.6. So why do we get the same result? Because when we square it, it makes everything positive. It's like the optimistic function. And if you're doing a gridded response, this is how you'd bubble it in. 13.6, bubble the 1, bubble the 3, bubble the decimal, bubble the 6. Because you'll have to do those for state testing later. Ooh, zip lines. You are harnessed to a cable that travels through the treetops. I actually did this in Costa Rica. It's super fun. You start at platform A and zip to each of the other platforms. How far do you travel from platform B to platform C? Each grid unit represents 5 meters. So what do? We see that platform B is at -30, -20. Call that x1, y1. Platform C is at negative 15, positive 10, and we'll use the distance formula. x2 minus x1, that's going to be negative 15 minus negative 30. y2 minus y1 is going to be 10 minus negative 20. And then we just start simplifying. Minus a negative 30 is plus 30. That'll be 15. Minus a negative 20 is plus 20. So 10 plus 20 will be 30. And then we just simplify. Punch it in the calculator. And you travel about 33.5 meters from platform B to platform C. So pause and see if you can figure out how far you travel from platform D to platform E. Okay, let's see. D is at 20, 20. And E is at 30, negative 15. So my distance formula is the square root of difference of the x squared, difference of the x components squared, plus difference of y components squared. Okay, so x minus the x is going to be 30 minus 20. Y minus the y is negative 15 minus 20. 30 minus 20 is 10, so that's 10 squared plus negative 15 minus 20 is negative 35 squared. So that's 100 plus 35 times 35 is 1,225. So that's the square root of 1,325, and that's approximately equal to 36.4. That was pretty cool. Eat some celery, and then do your homework. And I'll see you on the internet. Bye.